This is section 11.3, expected value. In this section, we're going to learn how to calculate the expected value of a problem. The expected value, also called expectation, is often used to determine the expected results of an experiment or a business venture over the long term. The notation for expected value is noted as E of x. Sometimes the expected value is called the mean value, and sometimes this mean value is said as to be x bar. So the expected value is an equation where we have E is equal to the probability of the first event times that event plus the probability of the second event times that event plus the probability of the third event times the third event and plus the plus the last event, the probability of the last event times the value of the last event. Notice we use the summation symbol as how we can look at the probabilities. So the symbol P1 represents the probability that the first event will occur, and A1 represents, if we're looking at winning or losing, the net amount won or lost if the first event occurs. It could also be a value like a score or some other value for that event. Again, P2 is the probability of the second event, and A2 is either a net amount won or lost of the second event or some value for the second event. So in this case, we're looking at a building contract. The Rich Walker Construction Company has just received a building contract from past experience. Rich estimates there is a 60% chance of making a $500,000 profit, a 10% chance of breaking even, and a 30% chance of losing $200,000, depending on weather conditions and other factors. What is the expected value of the company's contract? Well, in this case, we could set up a probability distribution with the values being 500,000 and 200,000 and 0, and then we could put in the probabilities associated with those events, 60% at 500,000, 10% at 0, and 30% at 200. Then you can see we can use the formula of our expectation, which is 0.6 times 500,000 plus 0.1 times 0 plus 0.3 times a negative 200,000. Notice for a loss we always use a negative symbol. So Rich's expected profit in this particular case, depending on weather, is about $240,000. So Rich has an expectation or expected average gain of $240,000 for this contract. Thus, if the company receives a similar contract like this one with these particular probabilities and amounts in the long run, the company would have an average gain of $240,000 per contract. It doesn't mean that for each contract he will receive on average $240,000. It just means over the long run his expectation based on the same conditions would be $240,000. You must remember there's a 30% chance that the company will lose $200,000 on any particular contract with these probability amounts. So here's the next example. When Josh Rosenberg attends a charity event, he is given an opportunity to purchase a ticket for the $50 door prize. The cost of the ticket is $2, and 100 tickets will be sold. Determine Josh's expectation if he purchases one of the tickets. Well, the probability of winning is 1 out of 100. The net winnings would be $48 because he paid $2 up front. Not winning would be 99 out of 100, and of course he would lose $2. So when we put that in the expectation model, we see we have 1 over 100 times 48 plus 99 over 100 minus 2. And when we look at this and we do the math, we end up with approximately $1.50 that we will lose every time we played this particular door prize. So just because Josh does it once doesn't mean he's going to lose $1.50. In fact, chances are probably good, 99 times out of 100, he will lose $2. But if he played the game over and over and over again for a long period of time, his net winnings would be approximately negative $1.50. This concludes our examples on expectation and expected value. We are now going to go to chapter 11.5 and talk about independent and dependent events.